C# interfaces. An interface looks like this in a bit of code. It looks rather like a class with the qualifying word interface. An interface allows us to use extra functionality in our programs. For example, we could use the sort or the for each in our code. An interface is also a specification. Let's see what that means later. For the moment, let's see how we, in practice, which at the end of the day is what you want to use, we're going to use an interface to allow us to sort. Now we've used a sort function before. If you want to sort an array of integers, for example, here we have an unsorted array of integers, and we want to use the sort function. So we've come across this before, and this does not ostensibly use an interface. So we haven't had to employ interfaces in our code, and if we were to run that ought to just produce an output, which is the array of sorted integers. But let's say we had a custom type which consisted of a set of integers I and j. So we have two arrays of integers, one containing the i's and one containing the j's. So you might be tempted to say, well, okay, let's try and sort them using the sort function. The only problem is that how does it know when it calls into the net framework, C# if you like, when it calls into C#, how does it know what to sort upon, whether it's I or j? And secondly, do you want ascending or descending order? Maybe we could signal that we wanted to sort upon I, and maybe we want to sort in ascending order. Well, unfortunately, that might be a simple way of doing it, but it just doesn't work like that. It is quite a bit more complex. What we need to do is implement an interface. So what we must do is implement the iComparable interface. Now, it starts immediately complaining. It says, does not implement interface iComparable compare to. Well, let's take a look at the help on iComparable. If we Google that, but what we need to do is take a look down here, the most important bit of all. When you implement iComparable, you must implement compare to as well. So that's exactly what I've done here. Now, at the end of the day, that's signaling that we're going to be sorting by I. If you wanted to change both of those i's to j, then it would be sorted on j. And the other thing is that if you want to reverse the order of sorting, that is to say, if it's ascending at the moment, then we'll make it descending, we basically change these two around, swap this and this, and that will change the order of sorting. Now we can use the array sort, safe in the knowledge that will be sorted as we wish. What is happening here, though, is quite complicated. What we're doing is this is giving an instruction, if you like, to the net framework. I want to sort my custom array, custom class, custom type, I should say, which contains two arrays. Now the network signals back, it sends a message back and goes looking for this function here, the compare to, with the instructions on precisely how you want your object sorted. So it's a callback, it's a little bit complicated. So first of all, I'll say it again, this goes off the net framework, but the net framework comes back to us and looks for this function, and if it doesn't find it, it gets quite annoyed. You saw that previously. If I were to comment that out, then you'll see that the iComparable should start getting annoyed because there is no compare to. So if I just get rid of that and run the code, then it should sort my objects upon I. So that if we put a breakpoint in and run our code down to this line here, then in the watch we can see at the moment, you can see I is 12, 10 and 14 respectively. Now if I just F11 and sort it, you can now see that the should be able to see that it's sorted. Well, I need to run this a bit further. So I've actually put another line in here so I can stop it on that particular line, and you can see that the I's are 10, 12 and 14. As an exercise, you might like to change the I's to J's and see that it gets sorted upon the J's. And as I mentioned before, if you reverse the order of these, you ought to be able to sort them in descending. So at the moment they're ascending, 10, 12, 14. If they're descending, be 14, 12 and 10. It is interesting as well to single step from here, this line here. If we do F11, you'll find quite strangely it goes up and calls this, I think it would call it 6 times, this compare to. So what you're doing is just comparing individual elements with the in the array to ultimately sort them. So you can see that being performed 6 times. You'll see indeed that the compare to function calls itself. Don't worry too much about that. So just know though the formality that you can see this in the help as to what you have to provide. So in summary, if you want to sort a custom array, a custom class using an array, two arrays, then we implement the iComparable interface, which stipulates that you must provide a compare to function as well. So when it comes back, it comes knocking on our door, it knows where to find the compare to.